Today we're looking at lesson 6.4, which is using elimination still, but you need to multiply first to be able to solve the systems of equations. So I'll show you how to do that. Step 1, you multiply at least one equation by a number or a constant to get two equations that contain either opposite terms or like terms. So, if you can see here, the original equations are in black. You have 5x plus 6y equals negative 8, and then you have 2x plus 3y equals negative 5. So, you can choose either to make the y terms the same or opposite, or the x terms the same or opposite. So I chose to make the y terms the same by multiplying by 2. And since I multiplied by 2, I need to multiply everything in the equation by 2. So I multiplied 2 times 2x to get 4x, which is the third equation, 2 times 3y to get 6y, and that is going to be 2 times negative 5 to get negative 10. So the equations that I'm going to use to solve are going to be the first and the third equations. Next, you do the same two steps that you would do to solve elimination. So you either add or subtract the equations, which eliminates one variable, and solve for that variable, or solve for the other variable, and then substitute that value into one of the original equations, so one of the equations that you did not multiply by, and solve for the other variable. And if it's x and y, you want to write the solution as an ordered pair. So for this one, notice you do not have any terms that we can cancel just now, so you're going to pick whether you want to cancel the x terms or the y terms, and then pick how you need to cancel it, or the multiplying part. So I want to change the x terms because that way I don't need to multiply twice. So I'm going to change the x terms to both be 6. So that means I need to multiply the second equation by 2. So that gives me 6x minus 14y equals negative 38. And I'm going to use that equation and the first one, which I'll rewrite, to solve. Now I have two terms that are the same, so I can subtract to solve. Negative 14 minus negative 2 is going to give me negative 12. Negative 38 minus 10 is going to give me negative 48. And then I divide by negative 12 to get y equals 4. And then I substitute it back into either one of the original equations. So the equation that's in parentheses or the top one. I'll just go with the top one. Plug in 4 for y. Oops. And I solve for x. So 6x minus 8 equals 10. Add 8. And then divide by 6. So x would be 3. And we'd write our answer 3, 4. And we're going to do this a few more times. Here's another one. Again, you choose which variable you want to make the same. So you multiply by, let's say we can choose to make them both 2q. So we're going to multiply the top one by 2. And I rewrite it. And now I'm solving these. So I can subtract. And that cancels out the 2's. So I get negative 15r equals negative 30. and r would be equal to 2. And then I plug it into either one of the original equations, so either the first one that's in parentheses or the second one. I'll choose the first one this time, plug in r, and solve for q. So q would be equal to -5. And we can write this either way, but we put it together, 2 comma -5. Here's another one. This time we're going to actually have to multiply both equations because none of these have any factors in common. So let's say we choose to make both the x's 10. That means I need to multiply the top one by 2 and the bottom one by 5. Now I subtract. And I'm dividing by Sorry, I fixed my mistake. 12 minus -50 is actually 62. So y would be -2. And then I need to plug this into either one of the equations in parentheses, the ones that are original, to solve for x. So I'll choose the top one. And 0 divided by anything is going to be 0, so x would be 0. So my answer would be 0, 2, or -2. Here's another one where we're going to have to take both equations and multiply to be able to get the same term and eliminate. So let's say I make the b's the same. That would make them both have to be 6. So I multiply the top by 3 and the bottom by 2. Oops. I'm going to need to subtract to be able to cancel them out. So a is -1, and then again I plug them into either original equation to solve for b. And b would equal 4. And either way you can list them, since there's no x and y, so it would look like that. And then we have one more equation where we're going to have to come up with the equations first and then solve. So this is talking about traveling down a stream. So a canoeist travels 4 miles downstream in 1 hour. The return trip takes the canoeist 1.5 hours. We need to find the rate of the boat in still water. So we're going to set up the two equations. First, we need to come up with our variables. Since we're talking about downstream and upstream, we need to think about whether we're going to get helped by the downstream or it's going to go away from us. So in this case, it's going to help us. So we're going to add our two variables, and that equals 4 for the distance. And then we're going to take the upstream, or the return trip, and that took us 1.5 hours. So we multiply everything, by 1.5, but it's also subtraction because we're going against the current, and it's still going to be 4 miles that we go. So if we set them up like this, we need to multiply the top one by 1.5 to be able to eliminate. So I multiply the top one by 1.5. And then let's say we're going to eliminate the x's, so we would subtract. So that gives us 3y equals negative 2. Or I'm sorry, negative 3y equals negative 2. So y equals 2/3. And then we plug it back into one of the original equations. So let's try the first one in parentheses. So we get x plus 2/3 equals 4. So x would be 3 1/3. And since the x represents downstream and the y represents upstream in still water, we're going to choose the x as our answer. And that concludes lesson 6.4.